Okay, our last lesson for trigonometry is going to be more problem solving. In this case, that deals with multiple right angle triangles that connect to each other. So we're going to focus just on the problems in 2 dimensions. The last problem in this is going to be a problem in 3 dimensions. You're not going to be required to do that part. So in the diagram, QS is 32 millimeters. We know that the angle from P to Q to S, or the angle of Q here, is going to be 50 degrees. And the angle at R to P to S is going to be up here, and it's 61 degrees. Use this information to determine the total length of Q to R. Well, I don't have enough information on the second triangle to solve for what RS is, because remember, I need to have at least 3 pieces of information. All I know right now is 2 angles. I don't know any side lengths, which means that I'm going to have to start by solving for the shared side length of P to S. I'm going to use the information that I have and say I have an angle, I have an adjacent, and I'm solving for my opposite, which means that tan of 50 degrees is going to equal the length of P to S divided by 32. I can also state that PS is going to equal 32 multiplied by tan of 50, which in this case, I don't want to round too much too soon, so I'm going to say that that's going to be 38.13 approximately millimeters. Now I know the adjacent side length to the angle of 61 degrees at the top here, and I'm trying to solve what the opposite is. So I'm going to use this along with the adjacent to solve for the opposite, which is going to be RS. And I'm going to say that tan of 61 is going to equal the opposite, RS or SR, doesn't really matter, divided by that shared side length we just solved, 38.13, which means that RS is going to equal 38.13 multiplied by tan of 61. And this is going to give me 68.79 approximately millimeters. And now all I need to do is combine my 2 side lengths. So I'm going to say that RQ, or QR, if we want to match the question, is going to equal 68.79 plus 32. QR, in this case, is going to equal 100.79 or 101 millimeters when we round to the nearest millimeter at the end. For example 2, it wants us to determine the measure of angle B to E to C. It wants us to solve this measure in here. Well, once again, I only know that this is a right angle triangle, and I know my hypotenuse here. So, like in most of these cases, I'm going to have to start by solving the shared side length. So in order to solve this side length, this is going to be the opposite. I know my hypotenuse here. So I'm going to say that sine of 39 is equal to the length of CE divided by 3.7. So the length of CE is going to equal 3.7 times sine of 39, and 3.7 times sine of 39 is going to give me 2.328 meters. Now that I know that, then I'm going to say that if I'm using this angle, I know my adjacent, I know my hypotenuse for this triangle. Cos of angle BEC is going to equal 2.328 divided by 4.6, which means that angle BEC is going to equal cos to the -1 of 2.328 divided by 4.6. And in this case, it's going to give me 60 degrees to the nearest whole degree. For example 3, in January 2003, the tallest building in Rockyville was the Metro building. Recently, a developer was commissioned by the Gamma Pro Oil Company to build a taller building next to it. From the top of the Metro building, the angle of elevation to the top of the Gamma Pro building is 24 degrees. So from perfectly horizontal, looking upwards, is going to be 24 degrees. And the angle of depression to the foot of the building is going to be 56 degrees. If the buildings are 45 meters apart, then determine the height of each building to the nearest meter. Well, the first thing that I can say is if I know that the angle of depression here is 56 degrees, then the angle of elevation, if I follow that Z shape, is going to be 56 degrees. So if I'm solving for the height of the Metro building, let's call it M, then I'm going to solve for the height of my opposite, which means that in this case, tan of 56 is going to equal my opposite divided by my adjacent, which means that the height of the Metro building is going to be 45 times tan of 56, which in this case is going to give me 66.71 meters. Or I can say that the Metro building is 67 meters tall. And I'm going to put that information in here, 66.71, which means that this height here is also 66.71 meters. Then I need to solve for this additional height of the Gamma Pro building. And once again, I'm going to be solving for the opposite side length using the angle of 24 and the adjacent of 45. Tan of 24 is equal to g divided by 45, which means that g is going to equal 45 times tan of 24. And 45 times tan of 24 is going to give me 20.03 meters. The full height of the Gamma Pro building is going to be the 66.71 plus the 20.03, and to the nearest full meter, then that is going to give me 87 meters. All right, like I said, if you really want to tackle it, you can try it. We're not going to test you on the problems in 3 dimensions. It's too hard when we can't do it in person to visually represent what this is going to look like. But if you want to take a shot at these, feel free.